Thank you, everyone. As Simon said, I'm Brian Tvenstrup. I head up the analytics team at an American marketing company. We work primarily in the business-to-business sphere, and we work in several different industries. Healthcare is one of them, actually, but I'm not here to talk about healthcare today. I'm here to talk about one of our other industries, which is construction and building products. And it's a very interesting tie-in to the keynote this morning. Mike spent a fair amount of time talking about the idea of event-based analytics and automated systems. And I think what I've got here is a kind of example of a similar framework that we've developed for, it's not quite as important as saving lives, perhaps, but still addresses some real needs in the marketplace. So let's see. Yeah, to get started, any Kagglers out here? Any people participate in Kaggle? Yeah, okay. Anyone remember this particular contest from earlier this year, actually, just in April 2015? Walmart sponsored a contest asking people to predict how the sales of different products in their stores might be affected by severe weather events, snow and rain. And so when I saw this contest, I participated, didn't do all that well, kind of finished middle of the pack. But it got me thinking about whether we could do something similar for our industry and for our clients. So there we go. Yeah, so we kind of developed, coming out of that competition, a set of questions that I had. And the first was, very simply, was there some kind of relationship between bad weather and sales data among the customers that we have in our building products division? The second question was, could we use that relationship, assuming we found one, to drive time-sensitive, really event-driven marketing to relevant customers? And then the third, which was also very important for this particular type of project, was could it be automated? Because as we'll talk about when we look at some of the data, it's not really something that's conducive to a manual operation. This isn't a kind of typical marketing campaign. So we wanted to be able to automate it, and of course, RapidMiner is the primary analytics platform tool that my company uses, so we wanted to do it all in RapidMiner. So we broke the basic problem down into 4 stages. The first part was, how do we actually get the data? Can we source the data? Can we do the ETL that's necessary to take the data from various sources automatically and transform it into some kind of a usable form for marketing? The second, and perhaps kind of the analytical heart of the process, actually was, could we then identify meaningful relationships between this weather data that we were looking at and the sales of the different types of products that our clients are selling? And could we understand both the timing and the magnitude of those relationships? The third piece was then, presuming we found some kind of relationship, could we actually segment customers so that we could treat them differentially, not just looking for kind of an overall relationship between sales and marketing, but understanding whether customers in segment A, B, and C are behaving differently with respect to these different event-based triggers. And then the fourth was, could we actually deploy this entire framework pretty much in real time, or certainly at least on a very regular schedule, and do it either via an API or some kind of automated batch transfer to really remove all of the manual and human steps. So for the rest of the talk, we'll just kind of walk through each of these 4 stages, and I'll talk a little bit about how we use RapidMiner to accomplish that. So in the United States, it's actually pretty easy, widespread availability of weather data. You can get weather forecasts, you can get weather historical events, and we looked at a number of different sources. The data source that we honed in on for this particular project is actually weather alert data that the National Weather Service provides. They basically put out warnings in advance of severe weather events of a variety of different types. So this isn't just your ordinary, run-of-the-mill, oh, it's going to be, nice sunny day today, 30 degrees out. This is like when there are severe thunderstorms or windstorms, if there are hurricanes, if there are floods, more severe weather events that might warrant some kind of an elevated response from the community. So the nice thing is this data is widely available. It's published in a RSS XML feed. It's structured in kind of an unusual way, though, or at least it's not ideal for us, it's structured by the weather event itself. So the National Weather Service will issue a severe thunderstorm warning, and then it'll contain all of the parameters for that particular alert, the date and the time, the geographic regions that are going to be affected, and they use a unique geographic region encoding, unique to the National Weather Service. So it's not based on latitude and longitude, it's not based on postal codes or anything else that anybody else may use. They've come up with their completely own geographic breakdown for weather events. And that's not, it's usable, but it's not very, it's useful, it's not very usable. And the volume of data is not super high. It's about 1,200 events per day, but it's clearly more than you're going to have somebody going through and manually reviewing. So you need something to deal with it. So this is an example of what it looks like. Again, kind of typical XML feed. Zoomed in here, you can see the kind of the key things. What the event is, when it's happening. What the urgency and the severity and the areas. Now, this is one of the things that we had to deal with the transformation, because there will be multiple areas listed within the same event, and we kind of want the converse of that. We want to be thinking about it from a marketing perspective of which areas are being affected, and so we need to break that down. So we built a little ETL process using RapidMiner, and kind of don't show you the whole thing here because it's quite lengthy, but broke it down into a few key stages. You've got the actual getting of the alerts with the web services. You're retrieving the information from the web page and then reading and parsing the XML. Then we do some deduplicating because there's some duplicates. They kind of publish the same event, and if they update the event, then they'll just publish it again and change a few things. Then we wanted to join it all together so that we could combine events. A lot of times the way the weather service works, for whatever reason, they'll say, oh, there's a severe severe thunderstorm alert from 5 to 6 p.m., and then they'll issue another one for 6 to 7 p.m., and then they'll issue a third one from 7 to 8 p.m. Well, that may be because they're not exactly sure about the timing as they're kind of issuing these, but for our purposes, we'd just rather treat that as one single event that runs from 5 to 8 p.m. So we've got some joining. Then we've got this geographic issue that I just described going on, where we've actually transposed the data so that we're recording it all at the geographic level rather than at the event level. And then we actually have to do some additional reading in to take these FIPS codes, which are the weather alert geography codes, and use them and make them into something more useful, which for us is the zip code, which is the US postal code. So you do all that, and you get this as a kind of a sample outcome. You can see very nice database structure. You've got a region, and then within that region, you've got an event and all these different attributes, and then when it starts and when it ends. And that's pretty much the form. Now, when we originally were doing this transformation, we were a little bit worried about data size because, again, what we've essentially done is we've taken one event, which might have 3 or 4 or 5 or 10 different regions, and we've now broken it into 10 different records, one for each region. But it turns out, after you do all the deduplicating of the overlapping events and things like that I mentioned earlier, the final data set size that you end up with, and if you strip out a lot of the extraneous things, is about the same size as the data set that you started with. So from a data storage perspective, it's not too onerous. This is just a sample of what it looks like. This was one week in July, I think. We took a few thousand events just to kind of, so you could get a sense. I don't know if you can really read this over here. These are color-coded. You've got heat advisories. You've got thunderstorm watches up here. You've got a lot of heat advisories. That's the red ones down here. You've got some flooding. That's the kind of the light pink ones over here. You've got some fire alerts. You've got a wind advisory section over here. Just kind of an example. It shows you what actually this stuff looks like. So, all right, now we've solved the problem of getting the data in and automating that using RapidMiner. Well, okay, but is it useful? What are you going to do with it? So we wanted to take a data mining approach here because there are literally hundreds of thousands of possible relationships that we could explore, right? We've got about 60 different weather events. We've got hundreds of different product categories across the different clients that we represent in the building products industries, everything from plumbing and electrical supplies, heating and air conditioning, construction materials, drywall, roofing. I mean, you name it, and our clients are manufacturing it. We've got about 30 clients. So the search space that we would have to look at it's hundreds of thousands of combinations. It's not something that you're going to put an analyst and sit down and tell them, go find an interesting relationship. It's certainly not likely to be very effective. So we built a process that essentially loops through, uses macros, heavily using macros and loops, to go through, read sales data out, restructure the data, and then automate the search process. I'll talk about the restructuring that we have to do. But this was all ultimately successful. It enabled us to search through a very, very large space of potential relationships and identify the ones that we thought were worthy of further investigation. So what is it that we're looking for? Basically, what we're interested in identifying are products where there is a distinct increase in sales right at the period that the weather event occurs, and then kind of return to normalcy afterwards. So this is, for the rest of the presentation, I'm just going to use this one example because it's kind of easier to follow the same thing through, but it's just one of many that I could have chosen. So the example that we're going to look at is air conditioner condensers, which are the units that make your air conditioner pump cold air, and heat advisories. So this is kind of plausible on first basis, because if you have a heat advisory, it means that you're getting severely hot weather in a particular area that taxes AC condensers above what their normal load would be. So units that are perhaps near the end of life are going to fail. Or if it's the first heat advisory of the season, so your air conditioning hasn't been on all winter long, now it's spring, you get a heat wave, and all of a sudden all these air conditioners are coming on, and many of them are failing because they haven't been used in many months. So you see, what we are looking for during this data mining exercise is summarizing, well, what was going on in the prior 4 weeks before the alert, what happened right when the alert occurred and maybe a week or two after to allow time for people to order parts and things like that, and then what happens after. We call that the prior period, the post period, which is right the time of the alert, and then the post afterwards. And if you look at this axis, what we had to do with all this data then, right, is we have to time normalize it. So we treat every event as time 0, and then look in the sales data at whatever calendar time that represented, look back 4 weeks, and then look forward 2 weeks, and then forward another 2 weeks after that. And we have to do this for literally every event that we're going to consider. And so, again, this is an instance where having a way to automate the data analysis here is critical, because this is it's an enormous amount of data transformation. When the sales data comes in, it's indexed by calendar date. It's not indexed relative to when weather events were occurring. So this is massive reindexing that has to occur. So in the example here, what we saw with the relationship between heat advisory and AC condensers was you had about a 35% increase in weekly sales right around the time of the event, and then it falls back pretty much almost to normal right after the event. So really kind of a perfect textbook example of what we're looking for, a bump in sales. And this is analyzed across, thousands and thousands of weather events occurring in all sorts of geographies distributed across the United States. So a fairly robust sample size. So great, what could you do? At this point, you already actually have useful information. If you're the manufacturer, you could start to increase production of particular products based on anticipated increase in demand, just based on what are seasonal weather patterns. You could also ship inventory. So if you've got AC condensers, you could use this information to say, oh, we've got some heat alerts going on in Texas. We're going to start shipping extra units to our distributors in Texas because we know that our demand is going to increase in Texas by 35% over the next 2 weeks. You could also increase your staffing for your service center, people who are handling warranty repairs or other service-related issues, because again, that there are going to be there's going to be an increase in the type of events that you're going to see. But we didn't want to stop there. We wanted to ask, well, could you actually drive this to the next layer down and understand how individual customers, these would be people who are actually purchasing the weather units, a lot of times they're contractors who are doing it for a homeowner whose unit has failed, and how they behave. So we looked at both supervised and unsupervised segmentation approaches. We played around with Kmeans. We also looked at decision trees and random forests. I'll show you a couple examples here. So the first thing actually we wanted to do was try to understand, well, what was driving the additional sales? In the case of the AC example, it's actually an increase in the number of distinct purchasers. You see this curve, which has the same x-axis, is very similar in shape to the other one, but this isn't dollar amounts, this is number of distinct purchasers in the period. So right around the weather event, you get this big increase in the number of people who are purchasing, but the average sale per purchaser is relatively constant. So this is interesting because it suggests that what you're getting is a set of incremental customers who are kind of opportunistically purchasing only around the weather event, and then they stop purchasing again afterwards. So this is useful because it means that, and this is just a three-dimensional, it doesn't quite render perfectly here, but a three-dimensional graph looking at, again, the prior sales, the post-sales, and the post-post sales. And you can see it clusters pretty cleanly. So we were able to use Kmeans clustering to assign people to various behaviors here. If you're here in the prior sales, and then you've got zero kind of behavior, but then you've got high behavior over here in the post sales. Those are those opportunistic purchasers. The people who are kind of out here in the cloud are kind of high in all three dimensions. Those are the people who are purchasing, all throughout the period. And some of these other points represent other behaviors. But this was fantastic. I mean, we honestly didn't expect it to be quite so clean. Usually, real-world data doesn't cluster so nicely. So we ended up being very happy with this approach, and consequently, we spent a little bit less time on the supervised approach. But we did look at whether or not we could predict, actually, whether or not you would be one of these incremental purchasers. Have an example decision tree here. We didn't want to look at what your behavior was related specifically to weather events, because if you're going to do that, then we might as well just cluster you, since everything is so clean there. So we only looked at other types of information, like what type of contractor you were, or what type of business you did. And it turns out you can build a decent model, a predictive model. A random forest operator gave us about 65% accuracy. That's about 85% area under the curve. Maybe you think, well, that's not so high, but in marketing, believe me, it's good enough. So we ended up, though, really moving more in the direction of the clustering because we had enough data and not a lot of brand new records coming in, so we could use just the actual cluster assignment. So again, at this point, what do you have that's useful? Well, you've got marketing messages that you can develop to explain to customers how these different severe weather events might drive incremental business, give them an opportunity to win market share. And I think critically for us, you can, if you are able to cluster the customers, you can differentiate your target marketing. So just kind of 3 example segments. If you've got loyalists, who are those people who are buying lots during all the periods, weather event or not, you probably don't want to give them discounts on AC condensers because you're just going to cannibalize sales you would have otherwise gotten. So maybe you want to give them a cross-sell opportunity instead. The opportunists are the ones that we were really trying to focus on identifying, and for them, maybe you want to give them incentives to purchase incremental units. So buy 4, get your 5th free or something to really drive that incremental value. And then, for people who are just non-purchasers, maybe if you know that they're unlikely to purchase at all, even given the weather event, maybe you want to give those people an attractive incentive to purchase that first unit to convert them to a purchaser. So the last piece, how can we then automate this whole thing? Because again, it's not like we want to have analysts, this army of analysts in the back room somewhere, tracking all these weather events and then doing all this segmentation. So we built the process. It reads in the data, it does the segmentation, does the clustering, and spits it all out. We're using a marketing platform called Silverpop. It's owned by IBM. It focuses on digital marketing. They have an API. I haven't quite got it fully integrated with RapidMiner yet, but I think we're pretty close. The idea is that we'll eventually just be able to send this outcome, as the weather events come in. RapidMiner is reading the weather events more or less real time. We pick it up every 10 minutes, I think. Then we'd just be able to send API messages out so that the relevant customers are getting email or text messages. But even if you don't have that, I think here you can still do a lot in terms of an automated process in batch mode, which is pretty much what we're doing now. So you can have a file generated from RapidMiner, which then gets sent to a network location, and then have some other marketing system retrieve that file and then send out the marketing events. It could be system to system, or it could be, again, batch mode. And the key is sending it really just to the right customers at the right time. The other thing that's important here, and again, Mike alluded to this in his keynote, is having a set of business rules to surround this to really manage the overlap, right? I mean, if you have one, there are a lot of severe weather events that occur together. You might have severe thunderstorms, and you might have flood advisory, and you might have high wind. Well, you don't necessarily want, you know, one customer getting 3 different treatments all at the same time, especially if they're somewhat contradictory. So you can use RapidMiner to build a set of rules in a hierarchy of importance, or a ranking of the offers that you're willing to present, and then manage, you know, how often a customer is going to be communicated to. Maybe if you sent them a weather event, you know, yesterday, you don't want to send them another one today, or something like that. So all of this is feasible within the architecture of RapidMiner as well. So that's pretty much it. Again, you know, it's, for us, a very interesting project. We're kind of in beta pilot mode now with a few clients who are going to be doing this. It's exciting because for us, it's a really good union of this event-triggered automated marketing and having a technology that really makes it all doable, all within one place, one platform.